I'm excited to show you a very special place here in Utah and meet up with an old friend who has been studying the geology and paleontology of the Eocene Uinta Formation for over 20 years. The Uinta Formation was deposited in a large, shallow basin that developed from the retreat of the Green River Formation lake system at the onset of the second half of the Eocene epoch. The sedimentology of the rocks indicate that the sediments were deposited in a broad series of fluvial or river deposits, indicating a large region of forested wetlands thriving in the humid, warm climate of the Eocene epoch, which today is now a dry, parched desert in eastern Utah. The Uinta Formation is exposed on the surface, covering nearly a quarter of the state, and hides beneath it a rich deposit of natural gas and oil. Drilling rigs have drilled into the lower geological units of this region, principally tapping into the oil and gas reservoirs in the Green River and Frontier formations in the subsurface of the basin. Nearly 90% of the oil and gas wells in Utah exist in this region of the state, representing nearly 30,000 active well sites and upwards to 100,000 abandoned well sites. Each well pad is about the size of a small city block, indicating an industrial complex that covers an area almost as large as the state of Massachusetts. To get around this maze of well pads and roads requires a unique skill set, since each of these 30,000 well pads require compressor stations, pipes, and roads to access. And this maze is constantly changing as new well pads are drilled and old ones are removed. Today, I'm using this skill set to meet with the world's expert on the Uinta Formation in the middle of the Uinta Basin in eastern Utah. The formation includes a mix of archaic mammals like saber-toothed horned euonythiers and large meat-eating mesonychids like Harpagalestes, but also an abundance of artiodactyls, ancestors to deer and pigs, as well as rhino relatives, and an abundance of brontotheres, twinned horned beasts that are also known as titanotheres. North America's oldest rabbits are also known from this layer of rock, as well as a diversity of rodents. However, one of the fossil discoveries that sparked interest in the formation was its rare occurrence of fossil primates. Today we're going to meet with Dr. Beth Townsend, a paleoanthropologist and professor of anatomy at Midwestern University, who has been studying the fossil primates from the Uinta Formation for over 20 years and has worked out much of the biostratigraphy of the formation. Tell us a little bit about Fantasy Canyon. What makes this, these weird...
These weird hoodoos.
There's weird hoodoos that
This is all
us.
Wind erosion, right? It's really neat because we're in this giant channel and the sand is very soft. That's why Fantasy Canyon is very delicate. But this is all wind erosion. It's amazing wind erosion. And it's interesting because the canyon, however, the water eroded out these main channels through these main sort of, I guess, you didn't say channels, you'd say like these kind of arroyos through here. The water eroded that out, cutting this channel into pieces. And then the wind came through and made all these beautiful little sculptures.
So the wind has blown these things.
Yeah.
Like these little delicate, little pinnacles and little, yeah, it's so cool.
It's very cool. So that's what made Fantasy Canyon. So.
Is there any other places in the Uinta Formation that's like this?
There are a lot of these. It's funny, these hoodoos, when they are in these big formations, we kind of call it goblin rock because they all look like gargoyles and goblins hanging down, right? And so there's a lot of places where you find this goblin rock, which is really just sandstone channels. And in this actual area where we're at, in the Fantasy Canyon area, if you were just to drive around on the oil well roads, you'd see some of it peeking out, but it's not as amazing as it is here in Fantasy Canyon. So
that's cool. That's cool. Exciting. I'm standing on an ancient river, an ancient Eocene river. This is what we refer to as a ribbon sandstone or a channel sandstone. Now the surrounding rocks are mostly mudstones, finer grained rocks, and this particular sandstone you can actually follow out on the surface here as it meanders almost like a road, a meandering road across the landscape.
What's neat about the Uinta Formation is it's the first time that scholars discovered that there was this different change within the Eocene where even the mammalian faunas became more modernized. We get the first distinction between caniform and feliform carnivores. That means dog-like versus cat-like. We get to see the first camels appear, the first pigs appear. You also see more distinctions within primates. So it's interesting because mammalian faunas become more modernized, and those archaic forms that were still hanging on, there are fewer and fewer of those as the Eocene marched on. And it's the Uinta time period where this happened, and the fossils where we first discovered these changes were found here in Utah in the Uinta Formation.
Cool.
Yeah.
So like if we had a time machine, we traveled back in time to the Uinta time period, what would it look like? I mean, today it's like this vast sort of badlands and desert, very hot and dry environment. What would the environment be like during the time that these rocks were being deposited?
Well, during that time period, what you would see is a very, like particularly right here in Utah, you would see a very distant, smallish lake that was clearly drying up, but the area would be full of streams and maybe larger rivers, but mostly smaller streams with tropical forests around them and some patches of just sort of like patches of like meadows, etc. that wouldn't have as many trees. So an area kind of similar to what you'd see maybe in, I don't know, like Georgia and Alabama and Mississippi, you know, where you have big rivers coming through with like dense tropical trees around them. Not tropical as in lots of palm trees, but just like dense deciduous trees where animals could live, lots of ground cover at the base of the trees. But then there would be sort of more open areas that didn't have as many trees. So that's what you'd see. So it'd still be very lush. It'd be what we consider more subtropical. In the earlier part of the Eocene, this area was covered in like closed canopy tropical forest, like you'd see in the Amazon. But in the Uinta, it was different. There were just the trees with the closed canopy, not the trees, but the streams with the closed canopy around it, and more open areas between those watery environments.
Oh, cool.
Yeah.
So you'd get things like crocodiles and alligators.
Alligators, river
sort of this
turtles, tortoises on land, turtles in the streams.
These turtles. And here we have an excellent example of a fossilized turtle. This is the plastron, which is the bottom part of the shell, the bottom shell that made up the tummy of the turtle. And the carapace, which is the top shell, is probably underneath this, still in the ground. You might see some of it coming up here. So this is a fairly large turtle that lived in these Eocene wetlands in eastern Utah. And then you said you find primates as well. Tell us a little bit about these primates. I mean, today, Utah is not known for having primates.
Exactly,
sure.
except for people, right?
Yeah.
And the primates that you would see here, in the earlier part of the Eocene, there was a really great big diversity of primates. But as we got towards the middle of the Eocene, that diversity decreased in the central part of North America, where we are now, central North America, Utah, right? So it decreased. So you would see little tarsier-like animals or small lemur-like animals or small loricines, like galago-type animals that were around. So again, we're not thinking monkeys, we're not talking apes. We're talking about small primates, maybe about so big that were more similar to the tarsiers of Indonesia, or the galagos, or the small, tiny lemurs of Madagascar, or the galagos of Africa. So small, and so that's what we'd see here.
So what happened to the primates? I mean, why does North America not have primates living, maybe not in Utah, but maybe like in other forested areas, maybe like other places? Did it just get too cold, or?
Well, definitely primates, all these animals, all primates except for some monkeys, right, really thrive in warm, humid, tropical environments. They need lots of trees. Primates either never come down from the trees, or trees are their refuge. And so you don't have a tropical forested environment, you're not really going to have primates. Now there are some exceptions of that with apes and things, and et cetera, in various, sometimes in Asia and also in Africa, where apes can live in larger swaths of land. There are monkeys that live in savannas in large groups, baboons, for instance. Yeah. But those are unique situations. In general, primates tend to be found in heavily forested, warm tropical environments. And so while there were the forested environments along the rivers here, and anyone can drive out into the Uinta Formation and see these channels that are still there. Like we're in a channel right now, right? Here in Fantasy Canyon. And so that was a river, and there was definitely big closed canopy trees around the river, right? So you'd find primates there. But basically what happened is that temperatures changed. It got cooler for about 9 million years. And so with that cooling, you know, the specialist primates that just couldn't hack the change in seasonality just didn't make it. And then as the Eocene waned on, by the time you get to the end of the Eocene at 34 million years ago, we're really not going to be seeing primates that we know of yet, because we haven't found them in the fossil record. In the Central Rockies region, we still see them in the same age rocks, which would be the late Eocene, late Uinta, early Duchanian of, like, for instance, Southern California and San Diego. We have primates there, but no
So they kind of
here.
moved south as the climate started to get cooler.
They might have moved south, or they just went extinct here, and the ones that were already in the south just stayed.
Were able to survive.
They were able to survive, yeah.
In addition to the fossil primates known from the Uinta Formation, there is geological evidence of forests that once ranged across Utah during the Eocene. I discovered some excellent ancient soil horizons in the rock layers called PaleoSoils.
Really nice. So a lot of biological activity in these ancient soils. And that's one of the indicators that you're dealing with the PaleoSoil, is that you see biological activity, and usually in the forms of roots that are penetrating down into these horizons. All right, any other questions? I think I kind of covered
Did you cover them all?
Oh, the one question I was going to ask you, I don't know if I'll include it, but what's like the coolest fossil you found in the Uinta Formation in those 23 years of...
23 years of working here, and the coolest fossil I've ever found. That's a good question. I feel like I haven't found any really cool fossils. You know, I'll tell you a cool fossil story. So when I bring people out here to collect fossils, I always say, pick everything up. I don't care if you think it's a rock, pick it up. And so a friend of mine, what we do is we go out during the day and we collect fossils and we bring them back to our camp at night, and then we spread them all out and we start to catalog them to do an initial catalog of what we think we have. And then when I take it back to my lab, I'll confirm what we think it is and everything, and then we'll start to do the science on it. We'll write it up, we'll describe it, anything. But my favorite story is a friend of mine, she was picking things up, and she puts out her finds for the day on the table, and she's like, oh, this is just a scrap of bone. And I turn it over, and I'm like, I think this scrap of bone has teeth. And then I wash it off, and it was an entire skull of a rodent that was like this big. And I was like, this is a skull. Thank you for picking up what you thought was a scrap of bone, because it really was a skull.
So some of these fossils are pretty teeny then.
They're very tiny, yeah. They're very, very tiny. So
I want to thank Dr. Townsend for granting me time to interview her during her busy fieldwork investigations in this remote corner of Utah. The rocks in the deserts of eastern Utah hide an ancient landscape of forest, rivers, rhinos, primates, and turtles, all fossilized in the rock layers of the Eocene Uinta Formation.